I hope all of you are doing good. Let's start today's chapter, Rational Exponents and Radicals. Introduction. In the previous class, we have learned integral exponent of rational numbers and the laws of indices obeyed by them. In this chapter, we shall learn the concept of rational exponent of a rational number and the properties of rational exponents. Number one, positive integral exponents. For any rational numbers a and a positive integer n, we define a raised to the power n as like this, n times. Here a raised to the power n is called the nth power of a. Further, a is called, okay, a raised to the power n. This is called base, which you already know because you have studied about this in your previous classes also, okay. And n is what? N is exponent, right? For example, you have a 4 raised to the power 5. That means you have to multiply 4 by 5 times. So here 4 is base and exponent is 5. This is base and this is exponent, right? Next, 0 exponent. For any non-zero exponent number a, we define a raised to the power 0 is equals to 1. Thus, 7 raised to the power 0 is equals to 1. Minus 1 by 4 raised to the power 0 is also 1, okay. Negative integral exponent. Let a be any non-zero rational number and n be a positive integer, then we define a raised to the power minus n as, how do we define it? A raised to the power minus n is equals to 1 by a raised to the power n, okay. Example, 3 raised to the power minus 4, you will write 1 by 3 raised to the power 4 and then 1 by 3 into 3 into 3 into 3. That is 1 by 3 3s are 9, 9 3s are 27 and 27 3s are 81. 1 by 81 is the answer, okay. Laws of integral exponents. In the previous class, we have learnt the laws of integral exponents. If a and b are any two rational numbers and m and n are two integers, then the following laws hold true. Okay, if you remember all these laws, let's just revise them all. See, a in raised to the power m into a raised to the power n is what? Base is same. Okay, so we will add the powers, that is m plus n. A raised to the power m upon a raised to the power n. Base is same, but both are being divided. So we will subtract the power, that is a raised to the power m minus n. Okay, a raised to the power m raised to the power n, we will multiply both these powers, okay, that is a raised to the power m n. Next is a b raised to the power n, that means a raised to the power n into b raised to the power n, okay, and a by b raised to the power n, that means a raised to the power n upon b raised to the power n, where b is not equals to 0, okay, and a by b, okay, a by b raised to the power n is equals to 1 by b by a raised to the power n, where b is not equals to 0 and n is greater than 0, right. Example 1, evaluate the following. 5 raised to the power 3 into 5 raised to the power 4. Okay, bases are same. So we will add the power, that is 5 raised to the power 3 plus 4 is equals to 7. That is 5 raised to the power 7. Okay. Let's do exercise 2.1. Write the base and exponent in each of the following. 3 raised to the power 6. 3 is base, okay, and 6 is what? You know that very well. 6 is exponent, okay. Now, positive rational exponent. We know that 2 raised to the power 3 is equals to 8 because 2 raised to the power 3 is 2 into 2 into 2. 2 2s are 4, 4 2s are 8, okay. So, we can express this relation as 8, 1 by 3 is equals to 2, okay. See, 2 raised to the power 3 is equals to 8, or you can say 8, 1 by raised to the power 1 by 3 is equals to 2. So, similarly, relations for raised to the power 4 is equals to 256 can be expressed as 250 1 by raised to the power 1 by 4 is equals to 4. So, in a general, if x and y are non-zero rational numbers and m is a positive integer such that x raised to the power m is equals to 0, we can say a raised to the power 1 by m is equals to x, okay. We can also write as y 1 by m as m under root y, or call it mth root of y. Thus we root second root, if we write second root of 9 is 2 under root 9, that is 3. Third root of 8, that is this 2. And fourth root of 81, we'll write 4 here, so 3, right? So using this, we may define x raised to the power m for a positive rational number m if x is a positive rational number and m is equals to p by q is a positive rational exponent. Then we define x raised to the power p by q as the qth, the root of xp. That is x p by q is equals to x raised to the power q raised to the power 1 by q. Okay, thus if x is a positive rational number, then for a positive rational exponent p by q is x raised to the power p raised to the power 1 by q is equals to x raised to the power 1 by q raised to the power p. Hence, we can define x raised to the power p by q in any of the following equivalent forms. Okay, so x raised to the power p by q is equals to x raised to the power p raised to the power 1 by q, or you can say q under root xp, read as the qth root of the pth root of x. Okay, and this is read as pth power of the qth root of x. Let's do example 1. Find the value of each of the following. 125 raised to the power 2 by 3. Okay, so how are you going to do this? 125 raised to the power 2 into 1 by 3, right? So how you will do it? You will write 3 here and then 125 into 125. Okay, 125 is 5 into 5 into 5 and 125 is 5 into 5 into 5. So we will take 5 into 5, that is 25. Okay, similarly you will do other examples also. Okay, now negative rational exponent. Let x be a non-zero positive rational number and m by n be a positive rational number. Then we define x raised to the power minus m by n is equals to 1 by x raised to the power m by n, or you can say 1 by x raised to the power m or raised to the power 1 by n. So thus we have minus, how we'll write this, 8 raised to the power minus 2 by 3. We will write as 1 by 8 raised to the power 2 by 3 is equals to 1 by 8 raised to the power 2 raised to the power 1 by 3, or you can also write it like 1 upon 64. 8 raised to the power 2 is 64, 1 by 3. Okay, then 1, 64 and 3 here. 1 by 4 is the answer. Okay, now laws of exponents for rational exponents. If x and y are any rational numbers different from 0 and a and b are any rational numbers, then we have the following laws of rational exponents. X raised to the power a into x raised to the power b is x is equals to a plus b, which we already know. X raised to the power a upon x raised to the power b is equals to x raised to the power a minus b. Third, see, these are same laws. Okay, so these laws can be verified by the following example. Okay, so first one, let's do it. Example 1 is 25 by 9 raised to the power 5 by 2 and then raised to the power 3 by 5. Okay, so first what will we do? See, 25 by 9 raised to the power half, 5 and 3 by 5. Okay, 5 by 3 we will write it as raised to the power 5, then 3 by 5, and then 5 by 3 raised to the power 5, 1 by 5 and 3. Okay, now 5 by 3 raised to the power, this will cancel. Okay, 3. So 5 raised to the power 3 is 5 into 5 into 5, that is 125. 3 into 3 into 3 is 27. So this is the answer. Radicals and radicands. We know that if y is greater than 0 and y raised to the power 1 by q is equals to x, then we can also write x is equals to this like this, okay. Hence the notations y raised to the power 1 by q and root yq represent the same value. The form y 1 by q is called the exponential form, and this form is called the radical form. This sign is called the radical sign, and this is called a radical. So here q is the index of the radical and y is called the radicand, right? Note that index of a radical is always positive, okay. Always note that. If q is negative in 27 raised to the power minus 1 by 3, then we do not write it as like this. We first write like this and then 1 by 27 raised to the power 1 by 3, and then we write it like this, right? Example. We have to express this in the exponential form, okay. So how will we do it? Radical, okay, this is radical. 729 1 by 6, okay. Now pure and mixed radicals. A radical that contains no rational factor other than 1 is called a pure radical. For example, these are pure radical. A radical which has a rational factor other than unity is called a mixed radical. For example, all these are mixed radicals, okay. Exercise 2.2, find the value of each of the following. 9 raised to the power 1 by 2. So you will write it like this, okay. 9 is 3 into 3. So answer is 3, okay. Things to remember. If n is a positive integer and a is a rational number, then a raised to the power n is equals to a into a to n factors. A raised to the power n is called the nth power of a. The number a is called the base and n is called the exponent of the nth power of a. 2, for any non-zero rational number a, we have a raised to the power 0 is equals to 1. A raised to the power minus n is equals to 1 by a raised to the power n, where n is a positive integer, okay. And laws of integral exponents, let a and b are any two rational numbers and m and n are integers, then we have these laws, okay. So go through this. If x is equals to r by s is a non-zero rational number, then we have this rule. For a rational number exponent p by q, we have this rule, okay. And if x is a positive rational number and m and n are any rational exponents, that we have these rules. 7, if x is equals to under root y and then q and then y 1 by q raised to the power 1 by q is exponential form, and this is the radical form of x. Here q is the index of the radical and y is the radicand. Number 8, a radical which has a rational factor other than unity, the other factor being irrational, is called a mixed radical. Okay students, I hope you have understood this chapter. Now you will do remaining questions.